Hi guys, this is Mr. Gran, and this lesson is the Day 2 portion of Section 4.5, Triangle Congruence using angle, side, angle, 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 side, and hypotenuse leg. If you were gone yesterday for Day 1, probably go back and fill in the notes for the Day 1 side so we're familiar with angle, side, angle, 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 side, and hypotenuse leg. And today's lesson is going to be the proofs on actually using the proofs with those. So it'll be 4 examples similar to 4.4 Day 2, and I'll just kind of talk my way through them here. And on Monday when I'm back in class, we will have a concept check on this and just get some kind of practice with it and some time to finish up homework and that sort of thing. Alright, so our first proof here, I'm just going to highlight some things that I notice with this right off the bat. So I see that I've got two, if you can see where I'm kind of highlighting here, 2 angles there that are congruent that's given information. Then I've got the 90-degree angle here. Well, I know that this is also a 90-degree angle on the other side of it. And then also I have this shared side that's going to be a reflexive property. So I've got 2 angles at the top, the shared side, and then the 90-degree angles at the bottom. This is a pretty good candidate for angle, side, angle. So here's how the proof is going to look. Alright, so for my first statement, angle UXV, so this angle that I'm kind of drawing out here with the little hand, is congruent to WXV, and that's given information because of the little arcs that are there in the angles. Alright, the second statement is that line segment XV is congruent with itself, and the reasoning there is reflexive. So we've got that shared side that's between the angles at the top and then the angles at the bottom that we're going to use next. Alright, the third statement is that angle XVU, so from X down to V over to U, is congruent with XVW, so the 2 90-degree angles at the bottom are congruent, and one justification there is that XV, this is perpendicular to UW, so that has to make a 90-degree angle on both sides here of that one. And the last part of our proof will be the statement UVX, from U to V to X, this triangle is going to match up with WVX on the other side. So U and V go together in the congruency statement. U and W go together, then V stays with V, X stays with X in our congruency statement. And the reasoning there, we've got an angle, a pair of angles, then that shared side, and then a pair of angles down here, so that's angle, side, angle. Now looking at this one, I notice a few things about this diagram to begin with. One, I've got 2 side length segments that are given that are congruent to one another, so there's going to be a side in here somewhere. Also, I've got lines that cross that make an X in the middle here, so that's going to give me a pair of vertical angles. And then you might recall these little arrows on each side here mean that these are parallel lines. And anytime we've got parallel lines in one of these diagrams, pretty good chance that we've got alternate interior angles, either right here and here or at A and E. So this is one where actually there are 2 different proofs that we can use for this, but we're only going to use one for this example. Alright, so the first thing that I said to start this is that angles B and angles D are congruent because they are alternate interior angles. If these are parallel lines, this is our transversal, then these are alternate interiors. Now, one thing before I go on, the symbols here, I don't have all the symbols available on the program I'm using, so you might notice that like this isn't exactly an angle symbol, this isn't really a congruency symbol, and the triangle symbol that I was using is not really a triangle. So you just kind of bear with me and use your imagination a little bit. Alright, so the next thing I'm going to do the given information, so BC and CD are congruent, and that again is given information from the diagram. All right, the next one I'm going to do are the angles at the vertical angle. So ACB and DCE, those are vertical angles because they're across the x from one another, and those are congruent angles. Now, with these angles, because they meet at this point here, I do have to use ACB and ECD to identify them rather than just B and D, because there's only one angle at point B, one at point D, but there's two angles at point C. Alright, then the last thing would be the triangle congruency statement, and again, not really a triangle symbol, but it's as close as I can get on this program. And A, B, C, A goes with E on the diagram, B goes with D, and then C stays with itself in this case. Alright, so for our third one, one thing is there's a little bit of missing information that I meant to put in there, and it might not be in your packets, and that's that angles K and M are congruent to one another. That's information that you're going to need for this one. Now what I notice is I've got two parallel lines again, so I've probably got alternate interior angles, and then I've got a shared side at NL, so I've got a reflexive property in there as well. So this is probably going to be an angle, and then a side, so let's see if that works. So my first step here, I'm taking care of some of the easy stuff, angle K, angle M, that's given information, so we'll start out saying that those are congruent to one another. So the next thing in the triangle, angle KLN, so this angle right here, that is an alternate interior angle with M and L, which is the angle right in this corner, and so those two are congruent. And then the second to last step here, the last part component is saying that NL and NL are congruent by the reflexive property. And then to finish off our congruency statement, K goes with M because those are the two given angles. Then L goes with N in the middle, and the reason is this L, the angle L from the top triangle here, is the one that's connected to the parallel line, but in the bottom triangle, angle N is connected to the parallel line. And then the last ones would be N and L, which would go together for pretty much the same reason. Okay, and now our last one, and this is the shortest one, it's going to be a hypotenuse leg. Now, one thing that we kind of need to be able to see here is how to split up the two triangles, and that's not always as easy as you might think. But if we split it up like this, so I'll kind of highlight one of these yellow as this one here, and then we'll maybe do the other one in red, would be this other one. As you can see, they sort of overlap, they share a side, so we're going to have a reflexive property there, but they're two right triangles, so they're pretty good candidates for hypotenuse leg. We've got a leg here that's congruent with this leg, that's given information, and then they're both 90 degree, they're both right triangles, and if we go across from the right angles, they both point to the hypotenuse, which is that shared side. So the first part, the way I did it, I went ahead and said that WV and XY are congruent, and that's our given information because they have the tick marks in there. Then secondly, my hypotenuse, WX, is congruent with itself by the reflexive property. Alright, and then our last part for our congruency statement, I started out with the yellow one, so WXY, and now W doesn't go with W for the red triangle, because W in the yellow triangle is connected to the line with the tick mark in it, and so is X in the red triangle. So that one starts with X. Then X for the yellow triangle is the one that connects to this diagonal that cuts through the middle. While in the red triangle, the equivalent is this line here, which connects to W, and then V and Y go together because those are both the 90-degree angles, and that is by hypotenuse leg.